Partial variation. When a variation is expressed as a sum of terms, we refer to that type of variation as partial. For instance, y is equal to k plus ax with y is partly constant, partly varies as x. The letter a is a constant of variation. If we introduce sin to k, say b, then we will have bk. But constant multiplied by a constant is also a constant. Thus, we do not apply another constant to a constant as we do to variables. The statement t varies partly as r and partly as inverse of s is represented as t equal to ar plus b whatever s. So what this means is that a partial variation is a type of variation where the relationship is expressed as a sum of terms. For instance, we can say c is partly constant. So if c is partly constant, we could say c is equal to k, and c is partly constant and varies or partly varies as x. So this part of variation where it varies to x, introduce a constant as, let's say, b x. So these two, where b and k are both constants. But in this case, where the statement says t varies partly as r, so you can say t varies partly as r. The key t is equal to k r plus, or we can say t is equal to a r, which is t varies partly as r and partly as inverse of s plus b 1 over s. So this part is the inverse variation, and this part is the direct variation. So both s and r are related to t by this formula. So this is how we represent partial variation. The cost of sewing a garment is partly constant and partly varies with the amount of time it takes to sew it. So let's take note of the way the sentence is, or the way the question was put to us. The cost of sewing a garment is partly constant. So I say cost is equal to, so introduce our first constant k, and partly varies with the amount of time. So if it varies partly with the amount of time, which means it's going to have another constant. Let's call that constant a t. So this part of it is a direct variation where the cost varies directly as the amount of time. So partly constant varies because of sewing a garment is partly constant k and partly varies with the amount of time. So this is the other part of it. Partly varies with the amount of time it takes to sew it. So this will be the formula connecting to, say, equation 1. Now we're going to look for the value of k and a, where both k and a are constants. So now when if it takes 6 hours to sew the garment, the cost is, when c is 6 hours, c is equal to 2,500, c is equal to 2,800 naira. So k plus et, k plus 6e is equal to 2,800, equation 1. So and when equation 2, so this is already in equation 1, when t is equal to 10 hours, if it takes 10 hours to sew it, c is equal to 10 hours, c is equal to 3,600. So k plus 10e, is equal to 3,600, equation 3. We're going to solve equation 3 and 2 simultaneously. Solving simultaneously 1 and 2, 2 and 3, that is k plus 6e is equal to 10, k plus is equal to 2,800, k plus 10e is equal to 2,600. So let's subtract k minus k is 0, plus 6a minus 10e will give us minus 4e, minus 4e, 2,800 minus 3,600 minus 800. So e is equal to minus 800 and minus 4. Minus cancel out minus. So 200. Therefore, e is equal to 200. So from 2, from equation 2, k plus, let me see, where we have a, we put 200 in place of it. K plus 6, 200 is equal to 2,800. 2,800 k plus 200 times 6, 1,200 is equal to 2,800. So k is equal to 2,800 minus 1,200, and k is equal to 2,800 minus 1,600. Now, so we've gotten the value of a and we've gotten the value of k, which are the two constants. Now, if we substitute these values into k and a in equation 1, we're going to get the formula connecting c and t together. So, from 1, c is equal to k 1,600 plus t is equal to 2 on 2. 1,600 plus 200 t. So this is the formula connecting t and c together. And the question will say, find the cost if it takes 4 hours or so. You can make the cost if it takes 4 hours to sew your garment is from this formula. C is equal to 1,600 plus 200 times 4, where t is 4 hours. So c is equal to 1,600 plus 200 times 4 is 800. C is equal to 2,400. Since it's cost, therefore C is equal to 2,400. Yeah. Y varies partly as the square of x. I'm taking note of this question. This part says y varies partly. It didn't say y varies. Okay, it didn't say y is partly constant. But I say y varies. So for the first part of the sentence, there's a variation. So y varies partly as the square of x. So y is equal to qx. This is the first part. Plus, the square of x, kx squared. I think I should use e because they are two constant. They're going to be two constant. Y varies as the square of x and partly as the inverse of the square root of x. So let's be b over 1 over square root of x. So this would be our relationship equation 1. So what we're going to do is to look for the values of a and b, which are the constants, after which we substitute them in place of a and b to get the formula connecting a, x squared, and root x together. Okay. So for us to do that, we need to solve with the values given for y and x. So when x when x equals to, when x is 1, y is equal to 2. So 2, okay, x is 1, so a squared plus b 1 over root, and x is 1, y is 2, x is 1, root 1 is equal to 2. So this is a plus root 1 is 1, 1 over 1 is 1 times 1 times b is b, so a plus b is equal to 2. This is equation 2. When x is 4 and y is 6, we're going to have e times 4 squared plus b 1 over root 4 is equal to 6, is equal to 6, yes. So 4 is power 2 is 16e plus root 4 is 2, 1 that's b over 2, that is equal to 6. So let's simplify this part of the fraction. Over 1, so LCM is 2, 32e plus b, a plus b equal to 6. Cross multiply is 32e plus b is equal to 2 times 6, 12. So this becomes equation 3. So now we need to solve simultaneously using elimination method. Using elimination method, solve simultaneously. Solve simultaneously. Solve simultaneously. So we'll come over here and say a plus b is equal to 2. 32a plus b is equal to 12. So let's subtract. This will cancel. A minus 32a will give us minus 31a. So 2 minus 12 will give us minus 10. Minus 10. So a is equal to minus 10 over minus 31. Minus will cancel out minus 10 over 31. So therefore a is equal to 10 over 31. So we say from 3, in equation 3, where we have a, we put this value here, 32, 10 over 31 plus b is equal to 12. So 32 times 10 is 320 over 31 plus b equal to 12. So b is equal to 12. We carry this to this side. 12 minus 320 over 31, so this 1. So b is equal to 31. Sometimes 3, 72 minus 320. This is minus 350, 22 over 31. So b is 22. Therefore b is equal to 22 over 31. But from the equation, so now we've gotten the value of the constant a and b. So e is 10 over 31, b is 20 over 31. So when you put them into here, so from equation 1, y equals to e, we have 30 minus 10 over 31 x plus b 22 over 31 root x. So this is the formula connecting y and x together. X squared, alright. Okay. And x squared. As you can see, need to make a correction here. 370 minus 320 is 52. This part of the 52. 52. Let me make something clear. When it comes to partial variation, just like direct variation, if x varies directly as y, we represent this as x is equal to ky. And if x varies inversely as y, we represent this as x ky. So for joint variation, where it's usually between direct and inverse, we say x, and it's usually more than two quantities. So x equals to x varies directly as m and inversely as n squared. So x is equal to n over k m over n squared. The case of constant proportionality. For partial variation, it has its own way that is being represented. So where we say x varies partly, or x is partly constant and partly varies, the usual form is either k, let's say a, a n plus b n, or x equals to k plus b b b, okay, let's say bz. So these are the two forms that partial variation is always found, and it all depends on the way the question is asked. For this one, it means that x partly varies as n and partly varies as n. So you see that x varies as n and as n. Why for this part, it means that x is partly constant. The first part of the statement in this particular case is that x doesn't vary, it's usually partly constant. That's why you have only constant here, plus or and, where this plus means and partly varies as this. So let's check here. In a question 1 here, it says a varies partly as this. So this first part of it talks about variation. So if you represent it, say a varies partly as b. If this was all we have to work with, and this is a direct variation, and if we introduce our constant, a is equal to k b, and then the other part says and partly as c, varies partly as c. So a varies partly as c. So this gives us a is equal to, let's introduce another constant, let's say p c. So since both of them are all related to e, or a varies as b and a varies as c, and we know that for partial variation, it's usually the sum of the two terms, the two other terms that vary with a particular quantity, which is in this case is a. This means that a is equal to kb plus pc. Check this. It is almost the same thing as 1 here and 1 here. So once the statement or the sentence tells you that a quantity varies partly as another quantity and partly as another quantity, it will end up in this form. But if it tells you that a quantity is partly constant and partly varies as y, it will end up in this form, which is equation 2. So where I say x is partly, I'm using x in this case, but here is z. So if you say x is partly constant, so k plus, and then it will go on to tell you that and partly varies as y. So for this partly varies, so you have introduced a constant which should be different from this constant. So let's say a y. So a and k are both constants. So these are two forms of partial variation, and both of them, to get the values of k and b, you need to solve simultaneously, and it depends on you whether you want to use either elimination method or substitution method. So just put this at the back of your mind and let's proceed. So I believe I've been able to lay foundation that will be helpful to proceed. And I didn't give that explanation earlier, but I felt I should do it before proceed with the examples I will follow subsequently. So in this case, number 1, a varies partly as b and partly as c. So e is equal to our first constant, k, and partly as b, so kb plus, I'm going to say p c. You can choose any constant of your choice. So this will be my equation 1. This will be the general equation connecting a, b, and c. Okay, so when E is equal to 4, B is equal to 2, and C is equal to -2, the formula would be 2k plus -2k plus -2p, which will be equal to 4. So 2k minus 2p is equal to 4. Here we should factor 2 out. We can have k minus p. K minus p is equal to 4. So divide both sides by 2. K minus p will be 2. So we can call this equation 2. Equation 2. So when A is 3, B is 3, and C is 1.5, the formula will be B3k plus 1.5p equal to 3. So this will be equal to 1.5. Right? Let me check something. Okay. 1.5 3k is 3 over 2p. You can solve from here right away. I want to do my solving like this. So 3k, I'm going to simplify this part. And it's the terms we have on the left side of the equation. So make it to over 1. And then look for the LCM, which is 2. 2 into 1 is 2, 2 times 2 is 6k. 2 into 2 is 1. 1 times 2 is 3p equal to 2. So 6k plus 3p is equal to, when you multiply both sides, cross multiply, 1 multiply everything here, 2 multiplies 3 to be 6. Now factor 3 out, 3 here gives 2k plus p, and that will give you 6. So divide both sides by 3, it gives 2k plus p equal to 2. So it's using elimination method, solve simultaneously. So equation 2 is k minus p is equal to 2, and 2k plus p is equal to 2 as well. Now I simply need to add for me to eliminate p, because minus p plus p will be 0. So k plus 2k is 3k, and 2 plus 2 is 4. So k is equal to 4 over 3. Now we need to look for constant p. So from, can use any of equation 2 or 3. So from this going to equation 2, from equation 3, and equation 3 is, where is it? Okay, and equation 3 is 2k. And in place of k, I'm going to put 4 over 3, 2 over 3 plus p is equal to 2. That is 4, 8 times 8 over 3 plus p equal to 2. So I'm going to bring this to this side. P is equal to 2 minus 8 over 3. And p is equal to, we get to the power 1, 3. 3 into 1 is 3. 3 times 2 is 6 minus 3 to the 1. 1 times 8 is 8. This is minus 2 over 3. So therefore, p is equal to minus 2 over 3. So we've gotten the value for p and the value of k in this equation of, from this relation, p and k are both constants. So now that both value the constants, we need to put the values into p and k in equation 1. So say from 1, a is equal to k k is 4 over 3 times 4 over 3b plus p minus 2 over 3c. But minus 2 times plus is minus, so p equal to 4 over 3b minus 2 over 3c. That's the formula connecting A, B, and C together. The question says, what is the value of C when A is 0.5 and B is 2.7? Let me use this part of the board. When A equals to 0.5 and A is 0.5 and 0.5 is equivalent to 1 over 2 and so B is equal to 2.7, which is also equivalent to 27 over 10. 2.7. What is C? Find C. C is so from our formula, A is 0.5, which is 1 over 2. So let me write. So from 1, from the formula, from the relation E is equal to 4 over 2b minus 2 over 2c. E is 1 over 2 equal to 4 over 3. B is 27 over 10 minus, and C is 2 over 3. C is 1 over 2. Okay, so 3 here, 1, 2 here, 9, 2 here, 2, 2 here, 2, 2 here, 5, and 2 here, 1, 2 here, 1. So 1 over 2 is equal to, and C is what we're looking for. Without C is not 1 over 2. So I'm looking for C. Is 1, 2 minus 2 over 2 is C. Okay. So here 2 times 9 is 18. 18 over 5 minus 2 over 2 is C. So I'll bring this one here negative, so I'll bring this part here and take this one to the side. So 2 over 2 is C. So 18 over 5 minus 1 over 2. 2 over 3 C is equal to, let's say 5 and 2 is 10. 10 into 5 is 2. 2 times 18, 36. 10 into 2, 5. 5 times 1, 5. So 2 over 3 C is equal to 36 minus 5 is equal to 31 over 10. Now I'm going to cross multiply. So this will give us 2C. This will give us 3. Okay, cross multiply. This will give me 2C is equal to 31 times 3 over 10. So I need to move again. So let me finish off here. So 2C is equal to 31 times 3 over 10. And C is equal to 31 times 3 over 2 times 10. So C is equal to 31 times 3, 93, divided by 20, 4.65. C is equal to 4.65. Z is partly constant. Z is partly constant and partly varies as y plus E y, where k and a are constants. So when going to question 1, so when z is, when y is 2 and z is 1, and z is equal to, when y is 1 and z is 2, the equation becomes q plus e times 1 is equal to 2. So q plus e is equal to 2, equation 2. And when y is equal to 2, when y is equal to 2 and z equal to 1, the equation becomes k plus e 2e equal to 1, equation 2. Solving simultaneously using elimination method. Using elimination method, k plus e equal to 2, k plus 2e is equal to 1. So subtract k, cancel k out, plus e minus 2e minus k, 2 minus 1 is 1. So multiply both sides by minus 1, so e will give us minus 1. From equation 2, k plus minus 1, which is the value of e, k plus minus 1 equal to 2. So k plus times minus give us minus 1 equal to 2. So k is equal to 2 plus 1, k is equal to 3. From equation 3, k plus 2e equals 1, where k is equal to 3, which is this, so 3 plus 2e is equal to 1. So 2e is equal to 1 minus 2. 2e is equal to minus 2. And e is equal to minus 2 over 2. 3 over 1, 2 over 1, minus 1. So therefore e equal to minus 1. So what's the value of, oh, I'm not supposed to call it here. We already got the value of my a, so there was no point getting it again. Gosh. Anyway, let me just proceed. So got the value of a and k, which is minus 1 and 2. So from equation 1 is plus z is equal to k is 3 plus e is minus 1 y. So z is equal to 2 plus 1 times minus 1 will be minus 1. Minus 1 times y will give us minus y. Z is equal to minus 1. So the equation, therefore, the equation connecting z and or connecting y and z is z is equal to 2 minus y. That's the equation. This is it. The resistance R to the motion of a car is partly constant. So the resistance R to the motion of a car is partly constant and partly varies. So our first constant is K plus, and partly varies as the square of the speed. So E minus B V squared. Equation 1. So when R at 80 kilometers plus, so the resistance is when R equals to 1060 Newton, V is equal to 80 kilometers per hour. And so our equation becomes k plus b, k plus b 80 squared is equal to 1060. So k plus 6400 b is equal to 1060. Equation 2. So when r is equal to, so okay, and at 120 kilometers per hour, its resistance 1460 into v is equal to 120 kilometers per hour. So k plus b 120 squared 1460 k plus 1400 b 1460 equation 2. So from 2 and 2 solving simultaneously, we're going to have k plus 6400 b is equal to 1060 and k plus 14400 b equal to 1460. And we will subtract. So when I subtract k, will be eliminated. 64 minus 144, there is a minus 8000 b and 1060 minus 1460 minus 400. So b is equal to minus 400 over minus 8000 that's equal to 4 over 84 over 1 for year 20. So b is equal to 1 over 20. So from equation 3, equation 3 is k plus 14400 b is equal to 1460. So where b is equal to 1 over 20. So k plus 14400 times 1 over 20. 1 over 20, 1460. So 14400 divided by 20, 144 divided by 20, 720. So k plus 720, 1460. K is equal to 1460 minus 720. K is equal to 740. So the value of k is 740, net of this 1 over 20. So from equation 1, r is equal to k 740 plus b equal to b is 120 g squared. What would be the resistance at 140 kilometers per hour? So when will be resistance when the speed v is 140 kilometers per hour. R is so let's look for R is equal to 740 plus 1 over 20 times 1 over 40 squared. 740 plus 1 over 20 times 19,600. 740 plus 19,600 over 20. 0 cancel at 0. So 1,960 divided by 2. So 740 plus 980. 1,720. 1,720. Therefore, the resistance will be 1,720 newton. The quantity y is partly constant and partly varies inversely as a cube of x. Y is equal to q plus q over x plus power 2 equation 1. So when x is 1 and y is 5, the equation becomes q plus q over 1 raised to power 2 equal to 5. 1 raised to power 3 is 1 plus q equation 2. When x is equal to 2 and y is minus 1, the equation becomes q plus q over 2 raised to power 2. 2 raised to power 3 is 8. So q plus q over 8 plus a minus 1. So simplify here. This is just LCM. 8 into 1, 8 times q, 8q plus q equal to minus 1. So we cross multiply 8k plus q equal to minus 8. Equation 2. So from 2 and 3, solving simultaneously. K plus q equal to 5. 8k plus q equals to minus 8. And you subtract plus k minus 8q will be minus 7k. Plus q minus q is 0. 5 minus 8 will give us 13. So k is equal to minus 13 over 7 from equation 2, which is k plus q. K plus q is equal to 5. K is minus 13 over 7, so minus 13 over 7 plus q is equal to 5. So q, bring this to this side, that's correct like terms. 5 over 1 plus 13 over 7. So q, LCM is 7. 7 to 1, 7. 7 times 5, 35 plus 77 1 times 13. So q is equal to 48 over 7. So the value of q is 48 over 7. And that of k is minus 13 over 7. So from equation 1, y equal to k is minus 13 over 7. Minus 13 over 7 plus 48 over 7 x raised to the power 3. That's the relationship between x and y. So equation 1 is equal to 1 equal to 2. And find the value of y when x is 3. So y is equal to minus 13 over 7 plus 48 over 7x raised to the power 3. When x equals to 3, y is equal to minus 13 over 7 plus 48 over 7 times 3 raised to the power of 3 minus 13 over 7 plus 48. 3 raised to the power 3 is 27. That means 3 multiply itself 3 times. So minus 13 over 7 plus 48 over 189. So I'm going to go for the LCM. 189. So LCM of 189 and 7. 189. So 7 to 7 is 1. 7 to 189 is 27. Plus 2 into 27 is 1. 9, 2 here, 1, 2, 3, 1. So 7 times 27 is 189. So LCM is 189. 189 divided by 7 is 27. 27 times minus 13 minus 251. So 48 plus 48. 251 minus 302. That is just minus 302 over 189. Therefore, 1 is equal to minus 203 over 189. This is equal to minus 1.603. So 2 equals to 2 decimal place 6. X varies partly as y and partly as the square of y. So x equal to q y plus q y squared. Equation 1. When y is 2 and x is 5, equation becomes 2q plus q y squared, which is 2 squared, is equal to 5. So 2q plus 2 raised to the power 2 is 4. So q is equal to 5. Equation 2. And when y is equal to 5 and x is equal to 57.5, the equation becomes 5y 5q plus q 5 raised to the power 2 is equal to 57.5. 5q 5 raised to the power 2 is 25. 25q 7.5. Equation 2. Solving simultaneously. 2q plus 4q is 5. 5q plus 25q is equal to 57.5. Well, in this form, we cannot eliminate any of the variables, so I'm going to make them alike. So I'm going to eliminate q. To do that, I'm going to make the coefficients of q the same. So I'm going to multiply equation 1 by 5, and it's going to affect everything in equation 1. That means I'm multiplying all through equation 1 by 5. So 5 times 2q is 10q. 5 times 4q is 20q. 5 times 5 is 25. I'm going to multiply equation 2 by 2. So 5k times 2 will give me 10q. 25 times 2, 50q. And 7.5 times 2, 115. So now I'm going to subtract 10k minus 10k, where the unit will be 0. 20q minus 50q will be minus 30q. 25 minus 115 minus 90q is minus 90 over minus 30 minus cancel. So 90 divided by 30 is 3. So q, therefore q is equal to 3. From equation 3, 5k plus 25 is equal to 0.5, where q is 3. So 5q plus 25 times 3 equals 7.5. 5q plus 25 times 3, 75, into 57, 5. 5k is equal to 57, 5 minus 75. 5k is equal to minus 17.5, and k is equal to minus 17.5 over 5 is equal to 7 minus 3.5 minus 3.5, which is equal to minus 7 over 2. So k is equal to minus 7 over 2, and then b is equal to, so k is equal to minus 7 over 2, and q is equal to 3. So the question says, okay, let's get the relationship between y and y squared, x and y. Therefore, from equation 1, x equal to k is equal to minus 7 over 2 y plus q plus 3 y squared is the relationship between x and y. Then when y is 5 and x, when y is 5, no, when y is 4, find x. When y is 4, x is unknown. So let's look for the value of x. X is minus 7 over 2 times 4 plus 2, 4 is the power of 2, minus 7 over 2 times 4. 4 is the power of 2 is 16. 16 times 2, 48. That's 48. 2 here 1, 2 here 2. 2 times minus 7, that is minus 14 plus 48, and that's equal to 34. So therefore x equal to 34.